Okay, my friends. So pie charts have their place. They for sure do. But you know what? A lot of people, a lot of statisticians in particular, don't care for them very much. They make claims, which I think are valid. They say things like, well, how do you expect your reader to differentiate between the size of a 6 slice and the size of the 7 and the size of the 8? And my answer is always the same. It's like, I don't. I make sure the graph does that for them. But I see their point. I totally get their point. As much as we think this is a two-dimensional representation of data, it relies on the width of an angle to represent the quantity. So it's really a one-dimensional representation. What I like about it is you get an idea of 100% and what each chunk makes up of that 100%. But I can see what they're getting at. So another way of looking at the exact same data is called a bar chart or a bar graph. I forget what Excel calls it. As I mentioned before, you've got those videos that show you how to make all these things in Excel on the resources page. So this is the exact same data, except it's bar graph form instead of pie chart form. So there's your pie chart and there's your bar graph. Exactly the same data. A lot of folks like bar graphs better, and I'm tempted, for this particular data set, I like it better, for sure. I don't like this as much as I like this, because not only do you get the same data presented, you actually do have two dimensions. You've got the horizontal dimension, which is the number of quizzes left to do, and the vertical dimension, which is how many people have that many quizzes left to do. I didn't label those very well, and I apologize for that. But this horizontal down here is number of quizzes left, and the vertical is number of students who have that many quizzes left. I like it a lot too because the 0 through 10 is what's called ordinal data. The order matters. 0, 1, 2, 3, 4, 5. Back in the pie charts where I showed you M&Ms and things like that, order didn't matter because red doesn't come before green. But in here, 0 comes before 1 and 2 comes before 3 and so forth. So I do kind of like this representation of the data in this way. And they're used all over the place. Here is one that I'm suffering through right now. This is this Thursday. Anybody who suffers from pollen allergies are dealing with this right now in Central Oregon. I put in my zip code, and this is the forecast. This was yesterday this is when I took the screenshot. It was yesterday. Today's Thursday. Might get a break tomorrow. Please, please, Mother Nature, give me a break. And then it starts creeping back up again. Whenever I see numbers like this, I think about what the numbers mean. Like, what is 9? What is 8.6? What is 4.4? And they tell us if it's this number, then it falls into one of these ranges, 0 through 12. And what they've done is they've broken those ranges up into 5 equal groups. But I still don't know exactly what the number means. The closest I've gotten to understand what those numbers mean is this paragraph. A pollen count is a measurement of how much pollen is in the air. Okay, that's easy enough. This count represents the concentration of all the pollen in the air at a certain specific time. It is expressed in grains of pollen per cubic meter over a 24-hour period. That's about as close as I've gotten. Grains of pollen per cubic meter. So I guess this number 12 is 12 grains per cubic meter on average. When it's red and orange, I'm sneezing a lot. And when it's green and yellow, I usually get a break. So that's how I read this chart. A good example of how to look at a bar chart, I like this one. This is the top 10 most oil-thirsty countries by total oil consumption. So what I did was I went into this site right here, which I think pulls from like the EIA site, and I looked at which countries on Earth consume the most oil daily. So we do, the United States does, followed by China, Japan, India, and Saudi Arabia, blah, 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 so forth and so on. This is how many barrels of oil each of these countries consume. So Mexico consumes just about maybe 2 million barrels. Saudi Arabia, maybe 2.5 million barrels. China, almost 10 million barrels. And the U.S., maybe 19 million barrels a day. 19 million barrels of crude oil a day, which is actually kind of a staggering figure. What I want you to think of is, this makes us look like the bad guy. So oil thirsty, twice as much oil consumed as China. I want you to think of one way this graph could be potentially misleading. It's not incorrect. These numbers were pulled directly from this database and then graphed. But there is another variable amongst these 10 countries that I'm not graphing up here. See if you can think about what it is. Okay, if you said, wait a minute, China's got a lot more people than the US, you're on the right track. That's exactly correct. So what I did on this next graph was same exact data, except I did what's called a per capita calculation. So I took, well, first thing I did was I converted barrels to gallons. I think a barrel of oil is hard to process. So I converted barrels of oil to gallons of oil. And if I remember correctly, and I probably don't remember correctly, you can Google this if you want to. A barrel of oil is something like 50 or so gallons of oil. When I edit the video, I'll Google it and I'll check and we'll see how close I am. So anyway, I changed it to gallons, and then I took that gallons number and divided it by how many people are in the country. So the US, this is still a staggering number, but I also think it's a little bit more reasonable. The US, a US citizen on average consumes 2.5 gallons of gas a day. Now, of course, let's not misuse what that means. That doesn't mean every single one of us uses 2.5 gallons of oil. It means if you took all the oil the United States uses and spread it out evenly over all the people, it would be 2.5 gallons per person. China is about a quarter of a gallon per person, or a quart per person in China. 1.5 gallons in Japan. Canada, if you look at Canada, uses about the same amount per person as we do. When you go back here, you're like, wait a minute, that can't, and then you realize, wait a minute. Yeah, Canada only uses about 2 million barrels a day, but there's also only about, oh my God, I'm gonna make up a number here. I think the number of Canadians is roughly equal to the populations of New York and Los Angeles combined. I'll also edit that when or I'll check that when I edit the video as well. Anyway, so I think this is a fairer look, the idea of a per capita. Take a number and divide it by some unit that is consistent across all of the groups you're looking at. I'll have you do that later in the homework. So one of the things I like to ask students at this point is, where do you think most of our imported oil comes from? We produce a lot of our own oil as a country, but of the imports, of those big ships that are bringing oil to our shores, which one do you think is bringing the most? And based on this graph, I think a lot of students look at this graph and say it's probably Saudi Arabia. And I believe some of that is rooted in history. So many images of Saudis or OPEC countries in general standing next to oil rigs in the desert. And I think that's very, very ingrained in our subconscious. In actuality, of the 9.1 million barrels that we import every day, 9.1 million barrels that we import every day, we use a lot more than we import, which tells you something about how much we're producing ourselves. Half of it, 49%, comes from Canada. Saudi Arabia is down here. They're in third place with 6%, just in front of Russia. There's Iraq at 4%. So when you think of the countries that you often think of with respect to oil, of our imports, in the top 10, we import from a lot more than these 10, but these 10 represent, 90+% of the oil. 10% of our oil comes from places you might associate with traditional oil images of, sheiks out in the desert standing next to an oil derrick. Half of our oil comes from Canada. So then I thought to myself, well, then why do we associate it with the Middle East? Maybe it's historical. Maybe it's because of the Iraq War. Maybe it's because of Syria. Maybe it's because it's been in the news. So I decided to look back as far as I could, and I went back to 1973. We imported 6.3 million barrels per day. But even then, Canada was still our main importer. Venezuela was right behind. Venezuela, I have a feeling I know why Venezuela, we're not importing from there anymore, but I don't want to turn this into a political science class. Just something to think about. I mean, and also I want to have you think about one more thing. Now that we're talking about oil, I'm going to ask you a question on your homework about this. Do a little Google research and figure out where oil was first discovered, where crude oil was first discovered on Earth. I bet you the answer will surprise you. Okay, let's look at, I made a little list of do's and don'ts for bar charts. And this is going to be a longer kind of video, and I apologize for that, but there's a lot of information and a lot of graphics I want to talk through. These dues are going to look exactly the same as they did for pie chart. So I'm not going to say too much about that. The only thing I added was axes labeled if necessary. I did label the axes with my bar charts, especially this one. I didn't label the vertical axis here on these, you may have noticed. And the reason is I don't need to. Well, these I did. I guess those two I did. But these two I didn't, because I put the labels on top of the bars. So yeah, that's kind of a choice you have. You can label the axes like I did here, or you could label the bars. As long as you do a good job with labels, your reader will know what you're talking about, and the graph will kind of speak for itself. This is the one don't, this is the one don't that really we need to chat about. Don't let your y-axis start at something other than 0. So you might notice that if you look at my charts, the lowest value horizontally here is 0. The reason for that is fairly obvious when you see charts that don't start at 0. And my favorite example of this is actually an old broadside. This is our school newspaper, an old broadside article where they were lamenting a tuition hike. This is a pretty old article. I think it's at least 10 years old, and that's fine because it's not the article that I care about. What I care about is the graphic that accompanied it. So what they did in this graph, and I'm going to preface this by saying their math is fine. Their math is fine. What they did was they took the old tuition and calculated what 8 credits would cost under the old tuition. And then they recalculated what it would be under the new tuition, which represented a $4 a credit increase. So you can check to see their math is fine. If the old 8 credit tuition was $528, then the new 8 credit tuition, since we've increased tuition by $4 a credit, if we have 8 credits, that's going to be $32 additional dollars. 32 added to 528 is 560. That's fine. 12 times 4 is 48. If you add 48 to 792, you're going to get 840. And 16 times 4 is 64. If you add 64 to this, you get this. And if you add 80 to this, you get this. So, I mean, the math is fine. It's not the math I have a problem with. It's the graph itself. So I want you to think about that for a second right now. See if you can figure out what's wrong with the graph. Now remember, this was all about starting the axis at 0. So here's the deal. If this distance right here is $32, then how can this distance be 528? I mean, if this is 32, which it is, according to math, then this 32, this is about just under $100, not 528. And the problem is, if this is indeed $32, if you drop 32 3 times and you drop to about 100, that means this line right here is not 0, it's about 428. And that line extends all the way across here. Now, why would they do that? Why would they do that? Well, I have a theory. Here's the graph started at 0. Here's the graph started at 0. Now, this is still $32, but do you see how this graph doesn't have the pow factor that this one does? And this one, students are going to go, wait a minute, I'm paying way too much in tuition. I don't like this new increase in tuition. Look how much more I'm paying. Well, yeah, I mean, it's $32, and I'm not trying to say that $32 is not a lot of money. I'm not trying to say that at all. What I'm trying to say is this is a fairer look at it, because in this, 32 is scaled correctly. If you actually tracked 32 back down from 528 here, you'd hit 0. Their graph starts at about here. And then what they did was they cut it and then stretched it down. And when they stretched it down, it exaggerated these distances right here. Everything got stretched like a shrinky-dink, and you exaggerate the differences. And that, my friends, is why, if you're not trying to be misleading, always start your vertical axis at 0. All right, so that was a lot of information about bar charts. Let's get into line graphs next, and then I think we're ready to move on to your homework.